All right, so welcome guys. So we'll take a look at today's tutorial, which should be about stacks, if I'm not mistaken. So we're at tutorial 4B. Yes, we are. All right, so what's a stack? Last class, you guys would have learned about queues, which essentially respects a particular way of operating, which is first in, first out. With stacks, it's now last in, first out. So essentially, the last thing that comes in should be the first thing that exits, which is opposite from the queue, which is the first thing that comes in would be the first thing that exits. So you can imagine like a stack of books, right? So let's say imagine you have a pile of books and you're stacking them one on top of each other. If you were to now take books off of that pile, you'd be taking from the last thing, basically the last book that you put onto that pile would be the first thing you take from that pile, right? So in stacks, the insertion and deletion elements occur at the same end of the list. The items in the stack are inserted last, will be removed first. So here they're saying essentially we're going to represent a stack as a tuple, where the first element, which is a tag, is just a string with the content stack, and a list with the contents of the stack, right? Now they're essentially saying the top of the stack and all operations of a stack work with the top. So you only need to know where the top of the stack is. So they're saying that the top of the stack is at the end of the list. So once we know where the top of the stack is, then we're good to go. Any sort of adding to the stack is going to be added to the top. If you're removing from the stack, it's going to remove from the top. So we're going to create our ADT. Should actually All right, so we're gonna essentially create our ADT now for making a stack. All right, so first function I'll make is the constructor, which is going to return an empty stack. By the way, you guys can see my screen well?
Yes.
All right, cool. All right, so that's the make stack. Let's look at what else we need to write. Contents. So let's write that contents takes a stack. I'm going to return the contents of that stack. So to return the contents, it will be just stack at index position 1. Then we have isStack, which takes a parameter and it's going to check if it's a stack. So a stack is a tuple. So we just use a type function to check if it's equal to a tuple. A stack has two elements in that tuple, so we can check the length. We can check the first element in that tuple to check if it's equal to a stack. And the data type for the second element is equal to a list. And that's it. So it's a tuple of two things in the tuple. We have the tag here and the... So when you're in the exam, just ensure that you check the tag and ensure you check your data type. So ensure at least those two are checked, then you should get your marks. All right, so we have push. So push takes a stack and an element as input and adds the given element to the top of the stack, right? Now remember they said the top of the stack is at the end of the list, right? So we're gonna grab, before we even write push, let me write the function is stack empty. The is stack empty is just gonna return true if the contents of the stack is empty. It means an empty list. Okay. All right. So push essentially is going to add something to the stack. Now push and pop are what we call mutators. So they essentially modify the data in your ADT. Now, before you write mutators for your ADT, it's important that you do some safety checks. Because you want to make sure that whatever you're changing is that thing, right? So before we push anything to the stack, we're gonna use is stack to basically check if it's a stack. So if it is a stack, then we are going to say contents at stack dot. Remember, we want to add to the top of the stack, right? To the top of the stack. Oh, you checked if it's empty. I checked if it was a stack as well. Okay, that's fine. The important parts to put this check is more so in the mutated, but it's fine if you added it here as well. You can add it there. So if is stack contents of stack dot append else, so basically if it's not a stack, we have two options. You can either print an error saying, hey, something is wrong here, or you can essentially make use of something in programming called an exception. So an exception is basically any fatal error that happens in your program. So you may have noticed this, for example, maybe in IDLE, maybe when you do something illegal like 4 plus A, you get some error like this, right? Your program crashed basically. That's what I mean by an exception, right? Or maybe you've gotten the blue screen of death on Windows, right? Something fatal happened, some fatal error occurred. So essentially, the program can't continue. So we can essentially simulate that same thing happening because we may want such that if it is not a stack, we don't want the program to continue, right? We want to make sure the user knows that, hey, something is definitely up and we can't proceed any further. So to do that, we use the raise keyword and then basically just specify what exception or what error you want to raise. So we can make use of errors that already exist. So one such is type error. And type error can take two things. So the thing that has a type error and the message for that error. So we can say not a stack. Right? So basically the user will know once the error comes up so that the program crashes, it will know exactly why. And it's because it's not a stack. Right? Now pop essentially we'll just remove from the bottom or the back of the list. So again, we're gonna check the stack. All right. Now, before I actually take from the stack, I also want to check if it's not empty. So if not is stack empty, because you can't pop from something that doesn't have anything, essentially. You can't take from a stack that doesn't have anything, right? So I'm just saying now, if the stack is not empty, So I pass the stack to check if it's not empty. Then I'm going to say contents a stack dot pop. So pop is a method on list or a function on list, and then I specify -1 because that's the last index position in the list, right? Else, so if it is empty, I can raise what's called an index error and say stack is empty. So this is just another error, and I'm just modifying the message saying stack is empty. If it is not a stack, then I can literally just copy and paste this. And that's that. So I think that should be everything. We'll have one more, which is top. So this just returns the element at the top. So just simply say return contents a stack at index position 0. You could add to this a check as well, just to check if the stack is not empty before doing this. Yeah, you could check if this stack is not empty before doing this. So we could have this here and then that, and then say else raise index error. Right? So basically it's saying that hey, if the stack is not empty, then you can return what's at the top. But if it is, then tell the user that hey, the stack is you're trying to get the top of something that is empty. Cool. Any question?
What is an index error?
Repeat?
What is an index error?
1 second. I don't think if you can type the question in chat, that would help. Not sure I'm hearing you clearly. Oh, you're saying what is an index error? Oh, good question, good question. Glad you asked it. So I don't know if you've ever this has ever happened to you guys, but whenever you're accessing a element in a index position in a list that does not exist, then you usually get an index error. In fact, I can show you guys an example of an index error. So if you guys are seeing my screen, let's say I create this list. Let's say we create this list. Let's say we'll only have like 4 elements in this list.
Somebody. Jesus Christ.
Right? So we have 4 elements in this list, right? So we know that the highest index position in this list should be index position 3. But let's say I did something like this. You see that? I try to access an index position that does not exist. And look at the error I get. See that? Index error. Right? Does that answer your question?
Yes, sir.
Yeah, okay. All right. Let's move on to the next question. So it says if the make stack constructor creates a stack, what would be the output of the following? So basically, we're gonna be testing out the stack that we just made. So I am going to save this and then run it. And then we're gonna test it out. So the first one is STK1. So if I just put STK1 in my Python interpreter, of course, I'm gonna get an error because I did not assign any value to that variable. Next thing is STK1 equal mink stack. Right? And then let's see what the value of STK1 is now. So as you can see, it's an empty stack. Then we're gonna essentially try to push something onto that stack. So it's a STK1, 3. All right. Now we're going to say STK1. Huh. You notice we don't see anything. Why is that the case? If we look back at the push function, you'll notice that this function doesn't return anything. You cannot assign a variable to a function that doesn't return anything. Right? To the function call of a function that doesn't return anything. Right? Because remember, when you're assigning a variable to a function call, you're basically saying that variable is going to have whatever the value is returned from the function. But if the function isn't returning anything, then you're saying the variable will have nothing, essentially. So the correct way to do this is after you make the stack, if you want to push something into the stack, you simply call push. That's all. Just call push. All right. All right, so then we have, well, all right, let me remake it again because I wasn't sure. So so push 1, then we'll push 5, then push 2. So if I look at the start now, you should notice, so 1, 5, 2. Cool, because we pushed all those 3 things onto the stack. Let's push 7. STK1, you should see 7. So notice every time I add something to the stack, it goes to the back of the list. Now, please note, and this is very important, the top of the stack isn't necessarily always going to be the back of the list. The question could have said that the top of the stack is actually at the front of the list. It doesn't change the overall principle of stack, which is you only remove and add to the top, right? So if the top of the stack was the front of the list, it means that you'd have to add to the front and then take from the front, okay? All right, so the top of the stack, since the last thing we added is 7, then we expect it to, whoa. Look at that, we got an error. We actually made a mistake. Remember, the top of the stack is supposed to be the back of the list. So this should actually be -1. So we're going to rerun this. So let me just copy over about this stuff. So please note, guys, that that there's a correction. That should be -1, not index 0. That's a common mistake that happens, so don't let that happen to you. Right. So if I do the top now, I am expecting to see 7, exactly. Pop. So we're going to pop twice. So if we look at the top now, so if we pop twice, we're expecting that the 7 and the 2 would have been gone. So at the top should now be 5. All right, so that makes sense. So someone said you'd use insert in that case. Yes, if the top of the stack was the first index position, then you'd say insert at index 0. All right, so you'd say something like, let's say you had this So lists, for example, have a insert. So it's a dot insert. Let's say you want to add 7 to this now. All right, so you notice it's now added to the front. Yeah. So that's if they said the top was thing there. The top, the front of the list. Any questions from? All right. The last topic for today. All right, so problem 3 says show the memory structure after the sequence of expression or this sequence of expressions. Right? So I have A equal 2, -3, 190, B is equal to A, C is equal to A colon, so it's slice, and C at 0 is equal to 42. All right, so what do we know from Python, right? We know that essentially, typically, when you have a variable, so let's say I say A equal 5 and I say B equal 4, right? I would expect, even if I say A is equal to B, I would still expect A and B to be separate values, right? Meaning operate separately. So meaning even if I were to add 1 to A, right, A would be 5 and B would still be 4. So me changing A does not affect B, even though I set them equal to each other. Now it turns out when it comes to lists, it doesn't operate that same way. When you're assigning a variable to a list, you're actually creating what's called an alias. So think of it like a nickname for the list. So let's say we have a list here with these values, 1, 2, 3, and I have another list. And let's say I say B is equal to A, right? Essentially, what happens here is that A and B are now the same list. So B is, think of it like a just a different way of going to A, right? So that means if I were to add something to A, it would affect B as well. If I look at A, we get 1, 2, 3, 4, and look at this. Interestingly enough, if I look at B, I also get 1, 2, right? So now that we know that, we can essentially use that principle to help us draw the memory diagram. The memory diagram is going to basically look like what you have here in problem 4. So let me quickly draw that. So I'm actually out of time. Supposed to have another class at this time, actually. All right, so right, so I have the first thing here, which says A is equal to a list. We'll draw the list with 2, 3, -190. So 2, 3, -1, and 90. Then it says B is equal to A. So basically, when I say B is equal to A, B essentially just becomes another way or a reference to A, meaning B now points to the same list that A points to. All right. Now it says C is equal to A colon. Now you might think that, okay, you would have C and then point it to the same list that A is pointing to. But no. The reason why is because there's A colon. A colon essentially creates a slice of the list. So it basically creates a new copy of the list in Python's memory essentially. So C will be pointing to a copy of A. So basically we copy all the stuff in A into a new list. And this is only because we're slicing the list and not just saying C is equal to A, right? And then we're saying C at 0 is equal to 42. So this just changes this. So it doesn't affect this up here because C has its own list essentially. And that's that. All right. Next question. So problem 4, given a sequence of Python statements, So look at the memory diagram and essentially, yeah. So if you notice, A is pointing at its own list with 1, 2, 3, 4. So A. So basically it's saying give the Python statement that would result in that. So let me actually just use Python. So it would get A, which is equal to 1, 2, 3. Let me look, is it 4? No, 1, 2, 3. And then if you look here, you notice B is pointing to a list with 2 elements. The first element is pointing to A, and the second element is also pointing to A. So basically, B is a new list, where the first element is pointing to A, so we can just put A here, and the second element is pointing to A, so we'll put A there, right? Now, given that we have this, we can answer the question down here. What would happen if you say A dot append 100? So let's see, if we say A dot append 100, right? And we look at the value of B, look at that. Isn't that quite interesting? 1, 2, 3, 100, 1, 2, 3, 100. Because essentially the first and second element of B is linked to A. So whatever it happens to A affects the first and second element of B. So if you notice, if I look at B, even though I didn't change B, I didn't like directly change B, because the first and second elements are linked to A, by changing A, it changed the contents of B. And that's that. Any questions?
Yes, sir. Could you please go back to the question paper?
Sure.
Yeah. I thought that the little rectangle beside A with the dot meant that that was another list that was beside A in a different variable. Like if you had a variable D and it had A and then it had, okay. I'm not accustomed to the memory structure looking like this. That's why.
Oh, yeah, it's just how they drew it. Yeah, it's just how they drew it.
Okay. Okay, thank you.
All right, cool. All right, guys. If there are no questions, I'm not exactly sure if there's a tutorial next week, but I'll be here if there is. So yeah. I'll be having a marathon for the exam, by the way, on the 6th of December, so that's next week, Saturday, online. Ensure that you're in the WhatsApp group for the course. So I'll provide the details for the marathon. It'll be free, on Zoom. Yeah.
Sir, unrelated question. Oh, sorry, go ahead.
No, you can go.
Yeah.
The quiz that we did yesterday, do you know what percentage of our grade it makes up?
No, I don't.
Okay.
So, sir, problem 4 is connected to problem 5.
Repeat?
Problem 4 is connected to problem 5.
Yes. The first two lines of problem 5 is the answer for problem 4. All right, cool. All right, guys. I will see you next week. All right, bye.